Hello, we're moving on to section 3.4 and we're answering the question, how do you solve a system of equations with three unknowns? A system of equations with three unknowns looks like this in this example. We've got three equations and three unknowns. If I have three unknowns, I need three equations to solve it. If I have two unknowns, I need two equations. If I have four unknowns, I would need four equations. The solution to this type of system is an ordered triple. It's got an x, y, and z coordinate. And if I was to graph each of these individually, instead of having a line, I'd have a three-dimensional plane. Okay? In your textbook on page 178, shows all the different possibilities if I was to graph these. So if I have three planes that I graph in a three-dimensional x, y, z axis, we could intersect in one coordinate. We could intersect in infinitely many coordinates like this, or we could have no solutions if we have any of these three situations. Okay, so in order to solve a system of equations like this, we follow a step-by-step process, and I've written it down here so you can write that down. Now we'll go through this example here and follow the three steps, or the four steps. Okay, so looking at our example here, the first step, it says to choose two equations and eliminate a variable. Okay, so I'm going to label my equations. This is equation 1, 2, and 3 here. Okay, so I'm going to take the first two equations and try to eliminate y. Okay, so if I'm going to eliminate y here, I'm going to have to multiply this first equation by 4 so I have an opposite. So I'm going to multiply 4 times equation 1. I should write it like this. 4 times equation 1. And that's going to be 8x minus 4y plus 24z equals negative 16. And this is just going to remain equation 2 here. And now when I do elimination, I'm going to eliminate the y's. 14x plus 19z equals negative 23. Okay, so step 1 is done. Step 2, take the unused equation, so I need equation 3, and one of the previous two, and eliminate the same variable, so I have to eliminate y again. Okay, so looking at this, if I need equation 3, I could use either one of these two equations, so let's just take and use equations 2 and 3. So I could multiply equation 3 by 2 in order to get an opposite here. So let's do that. So here, let's rewrite equation 2. And then I'm going to multiply 2 times equation 3, and I would get let's see what I get here. So I get negative 2x plus 5z equals 11. Okay, step 3, solve the system of two equations that resulted. So I have two equations here now with two unknowns, the same two unknowns. So now I can combine these systems into a system of two equations and two unknowns and do elimination. Okay, so I'm going to take this equation and rewrite it. And I'm going to take this equation and multiply it by 7 to have an opposite on the x's. So now I have negative 14x plus 35z equals 77. Okay, so let's add these up. So 54z equals 54. That's pretty convenient. So z equals 1. Alright, so we've got the z's. Now the final step is substitute to find out other variables. So we have to substitute backwards. So we can substitute this 1 into either one of these two equations to solve for x. Okay, so let's substitute this back in right here. So I'll get that. Subtract 5. So it looks like I get negative 3 for x. Finally, I have to take these two and substitute it back into one of the original equations to solve for y. Okay, so it doesn't matter which of these, so I'll try to find the one that might be the easiest, maybe the middle one because the coefficient is positive on the y, but it doesn't really matter. So let's substitute back in here. So we have 6 times the x plus 4y minus 5 times my z equals negative 7. So let's get negative 18 plus 4y minus 5 equals negative 7. So we got add 23, 4y equals 16. So it looks like I get y equals 4. So I have my x, y, and my z. I write my answer as a ordered triple. So x is negative 3, y is 4, and z equals 1. That's my solution. Okay, so if you can follow your step-by-step process, you should be able to find this solution. Now, going back to the beginning, when I picked my first two equations, there's many different ways you could have gone on this, but you should end up with the same answer. Looking back on it, maybe I should have started with equations 2 and 3 because I already had opposites on the z. So I could have eliminated the z's by just taking equation 2 and 3 and added them together initially, and the z's would go away. Then I could have chose equation 1 and one of the other two and eliminated z's as well. So you can see that there's more than one approach for each of these problems. What I would like you to do is take this equation, this system of equations, and go ahead and try to solve that, and then bring it to class tomorrow, and we'll see how many people can get the right answer to that, and we'll work through it in class. Let me just make sure I wrote it down right. Yeah, so go ahead and try to solve that, bring it to class. We'll see how many people got the right answer. This is the first video of 2 videos for section 3.4. In the next video, we'll look at a couple of special cases for systems of 3 equations and 3 unknowns.